For question number 7, it asks, explain 2 factors that activate or inhibit acetyl coenzyme A carboxylase and malonyl coenzyme A decarboxylase. What will each of these enzymes' activations cause to happen in the body? So, acetyl coenzyme A carboxylase, or ACC, helps us convert acetyl-CoA to malonyl-CoA, or MCoA, which will then help us go into lipogenesis to help store our fats. And going the reverse, going from MCoA to ACoA, is malonyl coenzyme A decarboxylase, or MCD, which will help us move towards lipolysis or breaking down our fats in order to utilize that energy to supply our body with the energy it needs to keep going. And so one factor that affects ACC, or us moving from acetyl-CoA to MCoA, is insulin. When we have an increase in insulin, that activates ACC. This makes sense because when we move from ACoA to MCoA through ACC, we are going into lipogenesis, or we are increasing in lipogenesis, which means that we're increasing storing our fats as for fuel for later. And when insulin is released, we're resting and digesting. We might have just ate, so we're taking in what we just consumed, and we're going to store it. We're going to store our glucose, and we're also going to store our fats through lipogenesis. And another factor that affects ACC is AMPK. When AMPK is activated, that means that there's a decrease in ATP and an increase in ADP and AMP, which means we're exercising. And so that means AMPK is going to inhibit ACC. We want to inhibit ACC here because we don't want our fuels to be stored in lipogenesis. We want to be breaking them down. So AMPK inhibiting ACC is important because we want our fuels to be broken down and not stored. Now going the reverse, going from MCoA back to ACoA through MCD, one factor that affects that is AMPK. When AMPK is activated because we are exercising, that is going to activate MCD. That is important because we want to use our fuel, break it down, and utilize it as energy to help fuel our body for the exercise that we're enduring. And so we want that MCoA to be converted back to ACoA through MCD, so we can send that ACoA back off to Krebs and utilize it to help resynthesize more ATP and increase our lipolysis. And then another factor that affects MCD is leptin. When we have leptin, that activates MCD, because when we have fuels, we want to break them down. We don't want to store them right now, and especially in this case, when we are increasing lipolysis, going from MCoA to ACoA, we want to break down our fuel. We want to break down our fats in order to utilize that energy again to supply our body for whatever we might be doing. And so overall, the activation of these enzymes is going to help the body either enter lipogenesis through storing our fuels through ACoA being converted to MCoA through ACC, or it's going to help our body enter lipolysis, or breaking down our fuels in order to use that energy to supply our body, and that's going from MCoA to ACoA through MCD.